Alright, hi. So this is basically just going to be a real quick tutorial that should allow you to get up to speed from not really knowing much about MATLAB to hitting the ground running. So I'm just going to open up this file here. This is basically an outline of what I'm going to do. I'm not going to go through it. I'll try to make this available for you all. But basically, I'm just going to give you a rundown of the orientation to MATLAB, coding basics, and basically how to create uh, functions, edit stuff, so that you can ultimately hit the ground running. Uh, so hopefully you can either play this video at a faster speed or just refer back to it if you have questions about a specific topic, and then use Stack Overflow, or MATLAB has a lot of documentation out there that should allow you to increase uh, whatever complexity you need for your topics. So for this first part, that MATLAB orientation, I'm going to start with the directory or pathway, and that's like this little white bar right up here. I'm using MATLAB 2019b, by the way. It might be a little bit different, whatever version you're using. Um, but this is the general layout. So here's the directory, the pathway. You can see starting at C, so my computer drive, users, AGD is just me. So it's on my desktop. We're in this folder called MATLAB tutorial, and you can see all the folders and things that I have files, right, that I have in this current folder window. I opened up one of the files that outline, right, you saw me open it. So this is the editor. If I close that down, it's not there. I can click on that again, it pops right back up. Over here on the right, we have workspace. So once we start, creating variables and stuff, stuff will pop up over here. We have the command window down here, so you can type stuff in line by line if you want, and do it that way, or you can just run your code from here. You can change the layout, so I just went to home rather than the editor. You can change it to whatever setting you want. I prefer the 3-column kind of layout. There's also one more thing I just want to show you, which is the command history, and I guess it's up right now. It's actually docked. It's just hidden over here. But this tracks all your history back to the beginning. I guess not the beginning of time, but just way far back. For me, it tracks it back to like February. So it overwrites it at some point, but I mean, this is months of data. I'm recording this right now in like June. So yeah, depending on how much you code. So let's just get that out of the way. Okay, so yeah, that's the layout, basically all that. So now we're going to start with coding basics. I'm going to open up this tutorial file. I'll share this with you as well. So there's a bunch of different kind of structures that you can use for data. So the first one I'm going to show you is just doubles, or essentially like arrays, which are matrices, are just ways of keeping numbers. So right now I've typed in the command window x is equal to 5. I could go up to editor and run this whole code, but it'll run the whole thing. So I'm just going to copy and paste line by line down in the command window. So we typed in this x equals 5, and it spits back out x is now equal to 5. And we can also see that in the workspace, we get this variable that has a value of 5. And we can also click on this, and it'll open up a new kind of tab that's for variables, and we see that x is here, and it's a 1x1 matrix or array of 5, value 5. So I'm just going to close that, come back to tutorial. MATLAB is case sensitive, so I can type in capital X is equal to 6, and it will create a second variable, so it won't replace the lowercase x, and now this capital X is 6. This other line is just capital X is equal to 7, and I put a semicolon after because each time this has been spitting out the x is equal to whatever. We don't need to know that. Oh, sorry, I didn't copy it. We don't necessarily need to know that. We're going to overwrite it, right? And this is actually going to overwrite the capital X is equal to 6 when we hit enter, but it's not going to show it to me. So you can see it didn't show me that it changed X, but up here we can see that capital X is now 7. So X is now overwritten as 7. The other thing I want to show you is I'm going to just delete that there. So when I get this, you can see I have this little red squiggly line. I can't name a variable that starts with a number. MATLAB just basically gets confused, so there are some syntax thing. It'll also put a red line right up here, and you can go to that line. If you're somewhere else, you could just click on it and see, okay, what's your issue here? So you can't run this. If you tried to do something like this, it's going to get upset and gives you an error. So that doesn't work. So I'm just gonna do that. But this will work. So if we say like x equals 2, or it even gives you options, right? Like it's saying maybe you want to say lowercase x is equal to 7. But I can do x2 is equal to 7. And now we have a different variable that's lowercase x2 is equal to 7. So that works. In addition to that, so these are just like scalar values, right? Just single values we can make of matrices. And to do that, you use these square brackets. And then the comma separates out columns. So the first row, the first column is going to be 1. First row, second column will be 2. And then the semicolon tells it to create a new row. So then that second row is going to start with 3 in the first column and then 4 in the second column. So I'm going to just do that to show you, because this is how I really like to figure stuff out too, is just play around with some example data and make sure it does exactly what I want it to do. And so you can see those commas, right, separated the 1 and 2 into different columns, same as 3 and 4. And then the semicolon creates a new row. So that's how you can create that. There's another, and this again is just a double value. And so we can also look at cells. So cells, you don't use square brackets, you're going to use those squiggly brackets. And so now I told it for that first cell, right, is going to be a 1. Second cell is just a 2. The third cell will actually be the first column, second row, 3, because I put it after this semicolon. And then for the fourth entry, I'm actually going to make it y. So it'll be that whole 2 by 2 double. So we can go over here and click on that cell we just created, lowercase c. And you can see that first row, first column is 1, 2, 3, and then you actually have y. And you can even click on this, like this might be a bigger matrices, and you'd see all your data like all the way through here. So this is a good way to organize huge data sets that you kind of want to clump together, is with cells. And the beauty of cells, right, is that if we go back to those variables, these all don't have to be the same size. You can't combine arrays or doubles that are different size, and so you can see that there. Okay, another type or structure that's pretty common are characters, or sometimes called strings. So we can create hello as one, that'll be A. And then B, I don't think MATLAB will allow me to do spaces. Let me see what it looks like. We can try it. Okay. And then we'll make C as world. And so now we want to create this little hello world that's almost always the tutorial of use. And so we're going to concatenate these strings and we get hello world. Okay, and it didn't include this space. But you can see it concatenated at least A and C together. And then you can actually concatenate them by treating them as a array. So each one of these letters is basically a different column. And so we can just write them together. And so you get hello world. Oh, and it actually did include the space there. Nice. Okay. Yeah, and then the final one we're going to talk about is tables. So for this, I'm actually going to set up car. So this will be a variable or a vector that's actually a cell. And I'm going to use these squiggly brackets. And that's because each one of these, like most common car models, are different lengths. So Explorer is obviously different length than Focus, you know, and stuff like that. So it won't work if we try it as a double. So I'll show you what happens if we do square brackets. It'll give us an error. And so it's telling us the dimensions of the arrays being concatenated are not consistent. So it can't align these because it's trying to put these right in different rows. It can't align those letters. So what we have to do is actually use the squiggly brackets. And once we do that, it works just fine. And we can see car is up here. It's a 9 by 1 cell array. It has all those values in there. And within here, right, within car11, we can call that one up. There's 1, 2, 3, 4, 5, 6, 7, 8 letters. So you can call those individually. So you could do car 1, 1. Say I'm interested in the third variable, or the third letter. Do that, and it tells me it's a P, right? So yeah, that's how you do that. Call that value. And then I've just also pulled off online the miles per gallon that each car of those get. So MPG is just another string or vector, actually, string of numbers here. So you can see, and that's a column vector of those MPGs. So now we can create a table by using this function table, this built-in function table, and that's going to concatenate car and MPG into a table, and it'll actually conserve these names for those columns, and I'll show you what that looks like in a second. So now T is the variable, right? And it's a table, 9 by 2 table, and we can see that that first column is still labeled as car, and the second column is MPG, and so you have all those values there. So that's also useful to kind of keep together different types of data and use them. So now we're gonna try to import some of these data. So we can change directories, which is a simple thing to do if you're trying to pull files from a different place. In this case, I'm actually changing the directory. If you can see it, it's basically the same as this directory up here, but to the additional files folder, which is right here. So when we hit enter there, we've moved inside that folder. So there's two kind of files in there. One of them is a CSV file and the other is the Excel file. They're both the same data. But so I'm just going to use this read matrix function and read in the CSV data first. So that's just data. So it created this. And now you can see this data in the first column is just a vector from 0 to 100. And then in the second column, it's the sign of whatever the value is divided by 100 times 2 pi. So what that means is it's cycling from sign of 0, so 0, all the way back to sign of 2 pi, which should again be 0, but that's essentially close to 0 since it's 2 times 10 to the negative 16. So this is essentially just one oscillation of sign. We can read in that same data using read matrix again, but for the XLSX. So read matrix is a super powerful thing for pulling in different types of files. We could specify a sheet. So in this case, there's just only one sheet. It's the first sheet. But if you had multiple sheets, you could say, hey, I only want to pull in data from sheet 3 or whatever. So we run that. I accidentally hit enter twice, but now we have data 1, and it's the same exact stuff as data. But it's just different files. You can also read in the stuff as tables. So I'll do that as well from the CSV. And so now we have data 2. And so now, again, like the main advantage to this is just that you get to see what those titles are for those columns when you pull it in. It also has that different structure. So if you prefer working in tables, like maybe that's easier. If you have data that's both strings and doubles or numerical values. And then the last thing is just always remember to include in your code to convert it back to whatever the folder you were in originally. It's just good practice, and that's because we have other functions in here that we want to call on or do whatever with. You'll have to come back to here. Otherwise, it'll still be in this folder and it won't know to call on these functions. So yeah. So simple arithmetic, you can do the same stuff. So x equals 5 plus 7, we know is 12. Created that variable, x is 12. It also records that, so since x is now 12, x minus 6 should become 6, and that's exactly what we get when we do that, so it will overwrite again. It also follows order of operation rules, so if we do this, 6 divided by 2 is 3, plus 2 times 1.5, so 2 times 1.5 is again 3, so x should just stay 6, and that's exactly what we get. So x is still 6, and Then we can also do other things like find the max. So this is looking at that data, and it's, in this case, we're using matrix notation. So data2 is going to call on this variable data, and it's looking at rows, comma, columns. So this colon here specifies that it's all of the rows of the second column. So if we look at data, let's go to data real quick. So it was all of these rows, like 1 through, I think it was 101, right, of the second column. So it's looking through all these values, and what it's doing is trying to find the max. So for a sinusoid, right, it should be 1, and that's what we get. We can also just check if we do that first column, it should be 100, right, because again, the data of the first row, it just goes from 0 to 100 by integers. We can do that same thing for the minimum value. So if you do min of that second column, minimum of a sinusoid is just -1. And then you could do the average. And again, since it's a sinusoid, right, that's oscillating around 0, the average should be about 0, which it is. It's like basically 1 times 10 to the -17, so essentially 0. There's also this cool thing, function called zeros, that will create a matrices that of your specification. So in this case, it's 2 rows by 3 columns of zeros. So that'll help you if you need to just create something of a certain size, and then you can change the values later. Because I can say z of 1, 3. So that'll be the first row, column 3. So this value here is now going to be equal to 1. So hide that, and then we can just type in z, and it'll show us we changed that. The other thing that's useful is nan. So this creates nans, or not a number, for all of the variables. We can, again, just change these values. I can switch them around just to show you that this will make a 3-row by 2-column matrix. So that's that. And then, again, size is really important. That's a good function to know. What size tells you is the rows and the columns. So if you want to know the rows of something, you can do size z, 1, and you don't care about the columns. That just gives you that 3. So in this case, we were looking at z, right? So z is the nans, and it's 3 rows by 2 columns. So if we just asked size z, 1, we're only looking for that first variable, rows. So there's 3. We can do the same thing for 2, and it gives us that there's 2 columns in that. For this, since z is a double, you can use length. So we could do length of z, and again, we already know it should be 3, because that's how many rows. But for tables, so we have a table over here, which is t, it's 9 by 2. We can't use that. So if we try to do length of t, we get an error, but instead you can do height of t, and it tells you that there's 9. So there's different ways of calling those things, and again, you can just kind of search length, how to use length for tables, or just literally copy and paste this into Google, check that. There's also these cool functions for cleaning stuff up if you want. So CLC, I just have these commented out for the time being, because if I run the code continuously, these will kind of just clear out all these variables, but CLC only clears out this command window that I'm working in here. So if you don't want to see all that clutter, you can do that. Clear all will delete everything that's in this workspace. So if I do that, everything's gone there. And then close all, if this will be important once we get to the graphs. This closes like all your figures. If you have certain figures that have their properties kind of hidden, you can use close all hidden, and it'll close down however many figures and like all the figures that you have. So if you have a ton of figures, like dozens, it's easier to just type this into the command window, close down everything. It won't close down this main MATLAB interface, but it will close all the additional figures. Okay, so now let's plot some stuff. This is going to call on the data. So if I just type this in, it's going to give me this error because there's no longer a data variable. So it's trying to look in this workspace for data. So I have to read in the data, and this again will also not work. And the reason it won't work is because, again, it's looking for this file, sinusoidexample.csv. That doesn't exist in this folder. So I actually have to use the change directory and then read in the data. and I'm going to change it back. Just out of good practice. Normally you can run this whole code and it'll do it on its own, so it's not a big issue. And so there, now we have our data. So we're going to go back down to the plot. Now we're going to plot data of row 1. So this will be the x-axis, and then column 2 is going to be the y-axis. So it's x comma y. It's the notation, and it popped up on the other screen, but I'll just pull it over. So this is what it looks like. You can see it's a sinusoid. The x-axis goes from 0 to 100, just like I said, and the sinusoid goes somewhere between 1 and -1. So you can also, I'm going to just click back on here so it'll disappear for a second. You can also change the color and do like a bunch of different things. I'm not going to get too technical on all the stuff you can do to the graphs in this, or figures in this video. But here's just an example. I've changed the plot color to red by putting color R. You can change this to like essentially any color, really. But just to give you an idea, like it's fairly flexible. Another cool, I'm gonna close that. Another cool function to use, especially when plotting, is linspace. So what this linspace does is there's 3 inputs. The first input is the lowest value you want. So I'm saying start at 0 and go to the highest value, which is 2 pi. So from 0 to 2 pi. And I want it to have this many breaks. So the length of data, all the rows of column 1. So if we look at data, all the rows of column 1, it should have a length of 101. So if I run this, it's going to spit out because I didn't put the semicolon afterwards. Don't worry about all this stuff. We'll just check it here. But so this is a row vector from 0 to 2 pi, so 6.28, right? And it is the same length as data, so it has 101. And so that was that length of data. So you could tell it, oh, I only want 10 points, and it would do that. So yeah, here I could just show you y is equal to linspace 0 to, let's say, 10. And if we want them to be integers, we could do 11, right? And then we'd get 0 to 10. You could do the same thing, but say maybe I only want 10 points. It will give you those values that go from 0 to 10 at that integer. Okay, I'm just going to clear that real quick. Okay, so you can also do, by the way, delete variables if you don't want them, by just individual variables, by just right-clicking on them and then clicking delete. And that way you don't have to clear out everything by doing clear all, which gets rid of everything in your variables. Yeah, and then we plotted that. So we have x. I'm going to plot x now, which is again just 0 to 2 pi by that second column of the data. So it's still the sinusoid. I'm going to drag it back over because it wants to keep popping up on my other screen. So it's the exact same sinusoid we saw before, going from 0 to 1, -1 to 0 again. But now instead of being from 0 to 100, it's 0 to 2 pi. And so I can still show you those two together if I just plot this. I'm going to use hold on to make sure it doesn't change anything, or replot over it, and then it'll plot the second, and let me just pop that back up. So here it is. So here's that. The first one it's plotting is the x, which is 0 to 2 pi by that sinusoid data. So you can see in blue that was the first plot, and it just goes from 0 to 6.28 like we saw before. And then the second plot, it's going to plot automatically in red. That's the default. It's doing data 1, which is 0 to 100, right? And again, it's just the sinusoid. So you can see them both there, and they're working just fine. Okay, so now we're going to get into loops. The simplest one is just like a for loop. So what I'm saying, I'm creating this variable I that is going to be the values 1 to the length of the data of all rows of column 1. And so all rows of column 1, again, this is just 101 rows, so it should be 101. So this I is going to be 1 to 101. And so then I'm creating this variable that I'm calling radians, and I've clicked on it here. It highlights all those variables later on. You don't have to pay attention to that now, but it's useful to know. But so I'm creating this variable radians, and I'm going to create that row. So in this case, it's 1 to 101. So rows 1 to 101 of column 1. So it'll be a column vector. And that value is equal to whatever that value or row is in the data, the first column of data, times 2 pi divided by 100. And so since we know this first column of data goes from 0 to 100, that this is going to basically convert that from 0 to 100 to 0 to 2 pi. And that's going to create that. So I'm just going to let it show you. So now we have radians, or rad. So that goes from 0 to 6.28, and it has 101, so same length. And that works. So I just want to show you too that this is how that I variable was created. So right now I is just 101 because it just does it for each loop, right? Each iteration. So you could do this and just see what it looks like. Again, it doesn't look super nice in the command window, but it just created this row vector that's from 1 to the length of that first column of data, so 101. So it's going through those integers. But say I only wanted to go from 1 to 10 at integers of 2. So it'll create a little smaller vector. So now I is just this. And so it starts at that first value 1, and it's going by integers of 2, and it stops at or before that last number. So in this case, right, if you start at 1 and go by multiples of 2, you can't actually make it to 10 exactly. You'd have to stop at 9 because the next value would be over 10. So that's something to keep in mind too. That's a useful way if you need to only look at a certain subset of your data. The next loop I want to talk about are while loops. While loops are a little bit quicker than for loops. And in this case, what I'm telling it to do is look at radians. So it's looking at this variable here. And it's actually looking at the last, or that end row first column, because we know it's only one column. And in this case, since it's only a column vector, you could actually just omit that one. You could delete that. It's the same because it just knows it's a column vector. And I'm saying if it is greater than pi, or while it is greater than pi, that last value in the column, then I'm going to say take that radian, that last value. Like I said, you don't need to put that comma 1, and you're just going to delete it. So these empty brackets just deletes it. So if we run this, it should kill everything or erase everything that is greater than pi at the end. And so it should be roughly half the length. So it goes down to 51 rows. If we scroll up, you can see, yeah, 51, it's essentially pi, which is great. So it did what we did. And then here's an if statement. So if, in this case, that column vector radians, the end row first column, is less than 2 pi, what I'm telling it to do is rename that variable the linear space 0 to 2 pi with 101 points. So again, this will just recreate that vector. But I'm just going to show you what this does. So now I just renamed it automatically because we knew it would be true. But so it didn't create a column vector, it actually created a row vector, right? So it's in the first row and it's created 101 from 0 to 2 pi as a row, and we didn't want it that way. Maybe we wanted it as a column. So what you can actually do is use this apostrophe, and the apostrophe transposes the matrix. So it makes all the rows into columns and the columns into rows. So you can do that. So I'm actually just going to run this while loop again, just so that you can see we cut the rad. Oh, I'm sorry. Yeah, hold on. So I got to do this because it was looking for the last one. So the reason it didn't work on that last round was because it was still a row vector. now I've converted it to a column vector, right? And it should be able to run because it was trying to look at the last row, which was essentially 1, and the first position. And that first position when it was a row vector was still 0, so it was less than 2 pi, so it didn't delete anything. So now it should delete that column. And now we can run this with that switch, and it should come back like you saw it here. It converted it to a vector, or a column vector, when I did that apostrophe. So if we run all of this, it brought it back to 101 and column vector. All right, so if you have multiple conditions or stipulations, you can also use like else if. So, you know, you'd say else if, and then whatever your conditional statement is, rad, whatever is something else. You can also just use else if there's only one other condition that you're concerned about. And then additionally, you can use the double vertical lines for an or statement, or a double ampersand for and statements. So just for a quick example, if the length of that rad variable is greater than 60, which we know it is since it's 101, or in this case, the last row of column 1 of rad is greater than 1.5 pi, and we know it should be because it should be up to 2 pi, then it's going to create this variable called check, and that will be 1, else check is equal to 0. And so this is useful too, like if you need to have a check before you continue doing a calculation, like maybe some of the data isn't worth processing, then you can do that. So check is now 1 because that was true. It's over 60 rows, and that last value is actually also over 1.5 pi. Cool. So isNaN is another cool function you can use with those kind of tasks for if statements or things like that. So again, we created this variable, and I have to scroll back up because I cleared everything. We created this variable z, which was that 2 row by 3 column vector. So you can use this function isNaN to determine whether or not some variable, so in this case it's just the first row, first column right there, is not a number. And in this case it's 1 because that statement is true. So if instead z row 2 all columns is equal to, we're going to do this. So now what I did was I just renamed that last row of z to be a 0 vector. You could have done zeros 1, 3, so that's like another way. I'll show you. So you can do and it's just the same thing. So that's a quicker way. Either way, it's the same. But so now we can check to see this other one. So isNaN. You could also check, I guess, rads, but isRad11. So that first row, first column, is that not a number, and it's 0. You could check different values. Yeah. So then you can also do some cool stuff with strings. So in this case, I've created 3 separate strings or characters. S1, which is just a lowercase hello, S2, which is hello with an uppercase H, and S3, which is just hello. So ultimately what we want to do is compare these 3 and figure out whether or not they're the same. In certain cases, so I'm just going to create these 3 separate characters. And now I'm going to compare just string 1 and string 2. So that was the lowercase hello, and then the hello with the uppercase H. And so again, this logical statement gives us a 0 because MATLAB does keep track of case. So because these cases are different on the H's, they're different. The other thing we can do is only look at specific subsets. So in this case, I'm telling it to compare string 3 which is just LO, lowercase LO, with S1, but only the end minus 1, so the second to last, to the end values. So it's just this right here from S1, that lowercase LO. So that should be true. They are the same. And we do get a logical of 1. So that is true. So you can also use that to kind of help you figure out what you want to do and compare files potentially for those if statements. So then finally what we're going to talk about is creating a function. So I'm just going to do something real simple, like x is equal to 5, y is equal to 3. Those are going to be our inputs. And then we're going to put it into this function that we're going to name example function. And then those inputs are just x and y, and the output 1 and output 2 will come out in our workspace. So output 1, we're just going to make it super simple, will just be x plus y. Output 2 will be x minus y. So what I'm going to do is you can either create a new script by hitting this plus, you can see that, or hitting Control N. You can also do new and create a new script. So I'm just going to hit this plus up here. So I'm actually going to cheat and just copy and paste this in here. And then also, since we have this description, it's always good to put a description of what these input variables and output variables are too. But I won't get into that as much. So you don't have to keep these the same. X and Y is pretty simple, but if you have these as other variables, it might be easier to just put them in as something else. But since it's an input, I'm going to change this to I1 and I2, just to make it short. I mean, again, X and Y is actually simpler in this case, but just to show you, we want output 1, we said was going to be x plus y, so in this case it's I1 plus I2. And we don't want to see it each time, so I'm going to put the semicolon, and then output 2 is I1 minus I2. Oop. And to make this a function, we actually have to type in function up top. I have the brackets here because I have more than one output, so we just need to separate those. If you just have one, you can just delete that and just type in whatever the output, single output is. And then you don't have to, but you can just close off the function by typing an end. And so now it's basically ready. We also don't need that there because this is just defining the function. The other thing I want to mention too is that, again, I earlier mentioned that like if you press on a variable, you can highlight it and it'll show you where it is throughout the function. So in this case, there's only 6 lines, but it shows you it's here in line 1 and as well in line 3. But say output 1 is kind of hard to write, or it's longer to write than you might want. So I can change that to O1. And now it's giving me this prompt that says press shift enter to rename the 2 instances of output 1 to it's just to O1. So if I have more than 2, it would do it for more than 2, but I can hit shift enter and it automatically changes the other variable. So that's useful. So I'm going to do that same thing over here, just so that our code is much simpler. And I should have done that beforehand, like just change it to O1 and then kept it throughout. But now all we have to do is save. So you can use Control S or Command S depending on what you have, or you can just use these save functions over here. So I'm going to save it, and you want to make sure that you save it with the same function name that you're going to call it with. So it pops up with that automatically, so I'm going to save it. And then you can see it's already popped up in this folder that we're working in. So, and it has a little different icon because it's a function. So we can come back to tutorial, and I'm just going to run these, and it's going to call up this code, and it spit it out already, and output 1 is 8. So we said it should be x plus y, which is 5 plus 3, so 8. And then output 2 is x minus y, so 5 minus 3, which is 2. And if, say, you had another iteration of this, where you have more data, where maybe x is still 5, but y is now 7. So you can do that same thing. And it will run again, all in that same line. And now output 1 is 12. Sorry, output 1 is 12, which is 5 plus 7, so that's right. and then 5 minus 7, negative 2, so that's also right. So it will overwrite it, but you could name these different things. So maybe this would be 3 and this would be 4. So now if you did this, you'd get output 1 through 4, and it'd all be conserved. So the other thing that we're going to talk about, the last thing, is just editing and debugging. So you can comment. I'm going to first show you how to comment. That's basically you just add in these parentheses, or I'm sorry, not parentheses, percent signs. So you can either add them manually by just typing in, for example, you just type in the percent sign and it all turns green and then it won't run it. Or you can come up here to the comment section in the editor window and just hit that, or Control R. This also removes it, Control T, or that button there. So that's something to be aware of. It's good to comment your code. You can also put in breakpoints. So say I want it to stop at a certain point, like right before here. I can just click on these lines here. You can also clear all breakpoints, set clear, and use these other functions for the breakpoints. That allows you to kind of control how you're going through the code. You can also control the options of how you run it. So if I wanted to run this whole script or this whole code, I could just click this button. You can also run in time, so you know how much time you spent on different aspects of that code. And then again, there's just different ways to run. So you can pause on errors and things like that, so that it's not going to run all the way through. But so let me try and run this code. And it already gives me an error. So I'm going to go through, click on that, and it'll bring me. So if I'm in a different place, whatever I was working at the end, I can click and it's saying there's some error in the file tutorial, right? And so it's because of this, right? So we should have seen from beforehand, there's this line here. So I'm actually just going to comment this out so that it will run. And I am just going to run it again. And I'll actually do the run and time so you see what that output looks like. So it ran all the way to that stop point. It did also pop up the graph. For some reason, it wants to do that on a different place, but or a different screen. But here's the timing. So it spent majority of the time on this tutorial, so this main script, and then it's doing all these other functions, these built-in functions, and you can scroll through that. So this is helpful if you want to optimize a code, figure out how you can shorten the runtime overall. So not super important if you're just getting started, but good thing to know. So basically it stopped on line 108 right before we did anything with these variables. So we have x and y, and it's going to go in and put those in for this function. So we can either do a single step or we can actually step into the function. So I'm going to step in, and what this does is it actually brings me into the function. Now all these variables are gone in my workspace except for the stuff that's important for this function. And then I can take a single step and see what happens. And so I see how O1 happened. So output 1 is 8. I can check on that. And you can just go through step by step, or you can hit this continue and it'll just continue running until it hits the next thing. You can also quit debugging at any time by hitting this button up there. And that's basically it. So you can step in, step out. I'm just going to continue, let it run through, and it's done. So it's gotten all the outputs 1 through 4, so we know it's done. It no longer says busy down here either, so that's how you know. And that's basically it.